Let me give you some more integration tips. So in the previous video, we've seen that when you try and integrate 1 over x, it gives you natural log absolute value of x plus a constant. You do need the absolute here, because if you were just to leave it as natural log of x, then it will only give you half of the solution. So in the future, when you do some integration and then if you were just to leave it as this, you're going to wonder what happened to the other half of your solution. So you do need the absolutes here. So let's just consider this. Hang on. So let's just consider y equals natural log of this thing here. So when you try and differentiate this, dy by dx equals, well, you would imagine this as being in the bubble. So it would be 1 over the bubble, which happens to be x to the power 3 plus 2x, and then you would then times the derivative of the bubble itself, which will be 3x squared plus 2. So this gets multiplied to the top. So what you will have then would be the derivative of the bubble over the bubble itself. So the point I'm trying to make is that when you try and differentiate the bubble, it will be 1 over the bubble. It will be 1 over the bubble, and then you've got to times with the derivative of the bubble itself. The derivative of the bubble itself. This gets multiplied to the top. That will then give you the derivative of the bubble over the bubble. So when you try and integrate this thing here, then you can go. You can just jump back to here. So hang on. So let's just consider this. If you try and integrate this, so get a graph plotter and plot this. It will then give you this. And notice that you do have the negative side as well. So for you to integrate this, notice that that this is the exact derivative of this. Notice that this, the numerator, is the exact derivative of the denominator. Then you can just jump to natural log absolute of the denominator You do need the absolute here. If you don't have this absolute here, if you were just to leave it as this, it will only give you this bit here. It wouldn't give you the negative side. It wouldn't give you this. So by you sticking the absolute in, sticking this absolute in here, it will then give you this and this, which basically will give you the negative side as well. So when you try and integrate something, try and keep an eye out for something being the exact derivative of another thing. Well, if this thing here is the exact derivative of this thing, then you can immediately jump to this. So when you integrate this, it will then give you this plus a constant. Okay, so for example, if you try and integrate something like this, notice that this is the exact derivative of this. Then you can just blindly jump to this plus a constant. Notice that this is the exact derivative of this. Then you can just blindly jump to this. So when you do integration, try and keep an eye out for something being the exact derivative of another thing. Then if so, then you can just jump to natural log absolute of the denominator plus a constant. Okay?